So I'm going to be talking very briefly about relapse prevention through smartphone-based digital phenotyping. This is a common theme we've seen so far, and the perspective I'm definitely bringing is a bit more focusing on some of the statistical issues. But to start with, we've thrown around the term digital phenotyping a lot, and how I'm defining it here was based in the 2016 paper from John Toros and J.P. Anella, the moment-by-moment quantification of the individual-level human phenotype in situ using data from smartphone and other personal digital devices. And while this definition is very general and very abstract, I'm going to talk a little bit about how we can make that a little bit more concrete. What exactly are digital phenotypes in the context of smartphone studies? So this is actually maybe a subset of, or if you take a magnifier to a portion of the graph that we saw from Justin Baker's talk, where if you have a patient with a smartphone and the first arrows leading out of the smartphone represent all the various behavioral measures that we can obtain based on the different data sources, be it mobility based on GPS, sociability, activity, sleep. So the four on the left there are all passively collected, and that's what I'm going to be focusing a lot on today. I think, in my opinion, a big focus of digital phenotyping studies should be on the passively collected data, because that's truly where this can scale. If we're asking someone to use their own device, which they would be carrying anyway, just being as unobtrusive as possible, I feel like that's what's really necessary to have a much larger scale health impacts. It's also only feasible if we can somehow limit the number of incentives and devices that are needed in order to get some of these studies up and running. So my focus is going to be more on those passively collected measures that you see on the left there. Now, for the quantitative people in the background, at the bottom, I put that down there because for those of us who are quantitative, that's what we want to see. The data matrix, the nice longitudinal rectangular data matrix where we say, okay, give me that and I can do some, I'll do my favorite statistical longitudinal data analysis procedures or time series analysis and whatnot. But getting from the top to the bottom, those processing steps I'm not going to talk about today, but they're also equally important. So even though I'm glossing over them, let's understand that that's a challenge going from top to bottom as well. So suppose we've gotten to the bottom, okay? And each row, you probably can't read that, but I'll just tell you, this is actually real data for one patient with schizophrenia, where each column represents a day, and each row represents a digital typing feature. So for example, distance traveled for a day, or time spent at home, number of people you called, etc., going down the list. So if each row is a different feature and each column is a different day observed over time, you can see that the data you end up getting is actually going to be very noisy. There's going to be a lot of missingness, and all of these need to be accounted for in the modeling stage. You can't always just plug and play your favorite machine learning method onto these, because oftentimes the amount of missing data is really non-negligible. Same with the mechanism of missingness. I'm not going to get into that today, but definitely something to keep in mind. So let's take a closer look at just two example digital phenotypes. So imagine we've taken these two, and these are actually made up, but if you could imagine maybe time spent at home would be feature one, because you have a spike of 2 days on the weekend. This might be for someone who works a 9-to-5 job on the weekdays. How do we choose to model these? What do we do with this data? One thing we can do is treat it like a time series like this. So at the top there, you kind of see what the actual data looks like, and then you can kind of see what the residuals are after you fit the data on the two plots below that. So these are two features that are being collected in sequence to one another. So one question when we get back to relapse prediction that we might want to look at is, okay, without any extra user input, can we detect if a behavioral change has occurred? We have all of these various, we have mobility, sociability, activity, sleep. Perhaps if they are all altered simultaneously, that might be telling as to some, maybe there's an escalation of symptoms leading up to something, which could inform an intervention before it's too late. So statistically, what the problem actually becomes is anomaly detection or change point detection, where we're kind of observing this multivariate data over time, and we want to know if a change occurs in that, how much time do we need? We want to kind of limit the number of observations after that change point so that we can know whether or not we can intervene. We should intervene. So let's take a look at a very practical example. This is going back to, this is from a pilot study conducted through collaboration with John Toros. This is actually back when I was a postdoc. I'm a very fresh faculty at Penn. I started in the summer, but before that I was in the Onella lab at Harvard, which is where I started working on these. And through that collaboration, we had, just a handful, 17 patients with schizophrenia who were followed for a couple months, where they installed BWE on their smartphone, and we had passively collected sensor data from each of these patients. Of them, 5 patients relapsed. Of the 5 patients that relapsed, actually only 3 relapsed over the course of follow-up. So we're talking about relatively rare events. And so, I think the general theme we've seen so far is that the stage of digital phenotyping studies right now are in the feasibility stage. And just as an aside, I think it's pretty clear, if there's my take-home message I've had from this conference so far, is that I think we're ready to make the conclusion that these studies are feasible, and we can maybe begin to scale this up. Because if we truly want to, the methods I'm talking about today, like change point detection or anomaly detection, things that are really important are knowing things like specificity and sensitivity. We can't do that if we only observe 3 or 5 events. We can't do that. We can only look at case studies. So this is, what I'm presenting to you right now is a very compelling example where, okay, so this is one of those 3 patients. I'll just walk through the graph on the right. Basically, this is, I think last December, this patient started collecting data, and then they relapsed 2 months later. And the relapse is shown, the data relapse is in red. And if we pretend like we go back in time to the day before relapse, and if we only had that data, would we have been able to know that a change in their behavior occurred prior to relapse? And with this patient, actually, there was a very strong signal. I'm just showing 3 examples. We collect many more than 3 features, but this shows, like, at the top is distance traveled in meters, minutes at home, and each point represents a day. And at the bottom is circadian routine, which is a number between 0 and 1, which 1 if they're following their routine perfectly, and 0 if they're doing something completely different in terms of it's their physical routine where they've traveled. So these are just kind of an example of 3 features observed over time, and you can see that they all actually do have a change that occurs at the same point in time, about a week before relapse. So in fact, with this patient, there was no reason why we couldn't have gotten this data and prior to their relapse, known that there was a change that occurred in their behavior which could have been automated to perhaps suggest an intervention. What we do with that information, I'm not prepared to answer. Maybe other people have ideas behind that. But, so who actually will do the intervention? But this is, at least in terms of being able to detect something, this is incredibly compelling. And overall in the study, we found that of the people who did relapse, the rate of kind of anomalies in behavior was much higher in the 2 weeks prior to relapse. So we can't say much more statistically at this point, or how well these models fit, without having more data rather than just a few cases. But I hope we can all agree that this is something worth scaling up. So the next steps, I'm primarily interested in the intervention side of things and the theory behind change point detection and whatnot in multivariate settings. But practically what this means is I am really interested in areas where interventions can be very helpful. So I feel like targeting vulnerable populations where we can really scale this up into prospective cohorts, such as like for suicidal ideation, schizophrenia, bipolar disorder. And this is definitely feasible, especially if we are not outfitting the sample with their own devices. I know there are some maybe, that is becoming more and more feasible, but that might be one of the only options if we really want to scale this up to a population level, especially for the study of rare events where it's certainly a necessity. So that's currently where we stand, but if you have questions about this, feel free to find me afterwards, or if you're interested in doing interventions in larger scales or curious about the methods themselves, talk to me as well. So thanks very much for your time.